Welcome to tutorial number 240, GHS model creation. This tutorial focuses on use of PartMaker. So where have we been before? So far we've covered the basic structure of creating models in GHS, the different parts types that there are in GHS, and so far we've focused mainly on creating GHS models using Rhino. Rhino's a very nice tool that you can buy as a third part to GHS. It's not sold through Creative Systems, it's sold through separate people. But there's another part called PartMaker, and we're going to cover that today. It's a fairly powerful tool, and when you combine it with Rhino, it really gives you the ability to do some advanced editing of your geometry parts. But first, a disclaimer. This presentation is for instruction purposes only. It is not to be used in engineering for construction, and I'm not a representative of Creative Systems, so this is just unofficial training. Now, if you do want the official training, Creative Systems does provide official training. You can contact them at the information below. I highly recommend it if you have the opportunity. Okay, so let's talk about PartMaker. First off, PartMaker, it's better to think of it as a part editor. Now, if this is part of GHS, so when you buy GHS, PartMaker is already included in it, and just like the rest of GHS, it's command-driven, text entry operated, but what it does do is it allows you advanced customization of the geometry model. Things like Rhino are set up to handle all of the standard scenarios. PartMaker, just like anything else in GHS, it has so much customization in it that it allows you to really identify and customize and optimize your model to exactly the way you want it. So how do you use PartMaker? Well, the general process is first you're going to start up GHS. You're going to enter PartMaker. I'll show you the commands for that later. Using PartMaker, you read in a geometry file, make any modifications, you write out the geometry file, and then you quit PartMaker. Now, just like regular GHS, all of these commands can be run interactively in the GHS window, or you can run them non-interactively, putting them all into a command file ahead of time and running it that way. So, let's do this by example. We're going to do homework number 241. This is an example of how to use PartMaker, and so you're going to use these commands below. It's a very simple thing. You're going to enter the command enter PartMaker, so that is the first thing that would be typed when GHS is already running. Okay, now you're now in PartMaker. You do the command read boat1.gf, so that's the read command to read in a file, and then boat1.gf, this is the name of your geometry file, and that's going to be a relative path from wherever you've started GHS. Comment, this just writes a comment to the geometry file. It's useful for things like revision history, keeping track of when it was last revised, who the last author was, that sort of information. It's not part of formal output usually. Write, that's the equivalent of saving the file. And you can see we've got a new geometry file name for it. So it's boat2.gf. And then finally, you quit PartMaker. Okay, now let's get on to actually how do you create parts in GHS. So remember, everything in GHS, all the model is made up of parts. You have to be able to create those parts. So you use the create statement. Now, there's a couple things here, a couple of the catches you have to know, I should say. This is the format for the create statement, and you start by the keyword is create, part name, \, component name. And the part name can be anything you want, following normal GHS naming conventions. Same thing for the component. If you don't specify a component name, then it automatically copies over as the same name as the part name. Now, when you create a part, the very next command you have must be the class statement. This tells it GHS what type of a part do you have. Do you have a hull, a tank, or a sail? So class equals hull in this case. Now if you don't put in this class part, it will assume that it's a tank part. So that's the default for GHS. And it's very, very critical. This has to be the very first statement inside your create statement. And then you're going to put in any part details that describe the part. We'll cover those later, but just the basic format here. You start with a create, your name for your part, you specify your class, any information about your part, and then more importantly than anything, you finish with a /. That's how GHS knows when you're done talking about that part. Really check for these / statements. I can promise you you're going to have at least one PartMaker file where you have forgotten to put in the /, and GHS gets very confused because it thinks that the very next create statement is part of the same part, and all sorts of interesting errors come out. So always check to have that /. The indenting, notice how I've indented here inside. That's not strictly necessary, but it does help with the formatting just to make the text files easier to read. Now, just like you can create parts, you can also modify parts that are already existing. And that follows pretty much the same format as the create statement. So you specify modify on the name of the part and component. Now this has to be the name of a part and component that already exists, otherwise GHS will throw you an error. You specify any changes and then finish off with a /. Now I do want to say, when you're looking at your different PartMaker files, be very, very careful. Read your file, your reference file very carefully, your GHS help menu, because some of the commands work differently in a create statement versus a modify statement. Same commands, but they have slightly different operation. Okay, so we've covered the basics of how do we create parts. Now the question is, how do you actually define geometry? Right now all I've told you is how do you create an empty part, but how do you actually enter in sections of a hull with coordinates? Well, to do that we have the locus command. Now the locus command defines a single transverse section. Remember, GHS works in sections, okay? And so what you're going to do with the locus command is you're going to give it a plane, a transverse section plane, and then you're going to specify the coordinates of the line of your ship or whatever your part is inside that plane. So let's look at the format. So the command is locus at L1 is your longitudinal location, and these are all in whatever units you've created for GHS. So if it's units of feet, then L1 is in feet. If it's units of meters, L1 is in meters. Equals, and then we have coordinate pairs here. T1, V1, T2, V2 going onwards and upwards. And so you've got transverse coordinate, vertical coordinate, transverse, vertical, all the way up to however many points you want. And you don't actually have to have the points close up, but this is basically you're going around and you're defining a section or a loop almost. So that's a transverse section. And GHS will automatically close between your first point and your last point. Now, let's say you wanted to create a step change in height. So, for example, if I look at the geometry definition for this barge, let's zoom in here, maybe not that much. Yep, so we're looking here at this barge where we've got a jump in our forecastle deck. That's a step change in the section shape of our hull. 1 minute there's here the hull, the next minute there is nothing. So the question is, how do you create that? The way you do that in GHS is you actually create that with two sections. The first section is just before the step change, and the second section is just after the step change. And they're going to be the two sections will be very closely spaced together, but not directly on top of each other. So they can't have the same longitudinal position, but they can be close. Okay, so let's see, how do you combine that with defining parts to create an actual hull part? So the first thing you do, okay, so we've covered so far how to define a part and how to define geometry. But how do we combine those to actually create a hull part, for example? So a hull part is clearly what you need to define the hull of your body. And so this is going to cover how we combine those. So as you can see, we first use the create statement. We specify hull.c is the name of our part. So you can see here the .c, this is our naming convention to specify the sides of the, or the sidedness of our part. So because it's .c, GHS is automatically going to mirror anything we define. So that means we only have to define the starboard half of our hull. GHS will automatically mirror it over to the port half. And then what we're going to do is we're of course going to create our class statement to tell it that it's a hull. Otherwise it thinks we're going to create a tank, and that's not what we want. I should also mention that by common convention, your main ship hull is actually given the part name of hull, of H-U-L-L. And that's mostly just convention. There's nothing that strictly requires it to be called a hull, but it very much helps everybody if you give it that name. Okay, so then what we do is we have a list of locus statements, however many it takes. And for complex ships, this is going to be a very, very long list. And that's a case where you might want to do it in Rhino instead, rather than typing out these coordinates for every single section. But you type out your locus statements, one after the other, for every single one of them until you've defined your hull. And then what you do is you type the spacing. And see, this is a very important thing that's going to save you a lot of time. Now, GHS has quality requirements for defining your hull shapes. It requires that the spacing between your sections has to be at least, at a minimum, or excuse me, a maximum. It has to be a maximum of 1 divided by 25 times the length of your ship. So 1/25 of the length of your ship is the maximum spacing that you can have between sections. Now, a lot of people think that means that they have to have a locus statement at least every 1/25 of their length. Not true. There's a nice trick here. The locus statements, just put them where you need them to define the changes in your hull. And then you're going to specify a command called spacing. And spacing is going to actually be where you'll tell GHS what is the maximum spacing that you want between these stations, between these section shapes. And then GHS is actually going to look at the defined locus statements you have and interpolate between those locus statements to put in sections at the spacing that you've requested. So that's a major time saver for you. And then of course we have our / to close off the command. Okay, so let's do an example of this so that you can get some practice with it. This is homework number 242, and I would like you to use GHS with PartMaker to create a very, very simple hull form. This is a canoe, and it has only 3 locus commands with it. So I've intentionally made this simple so that you don't have to spend a huge amount of time typing commands, because if you can get the command done correctly once, you can do it 100 times. And what I want you to do is I want you to create the canoe using only 3 locus commands, but you're going to finish with a station spacing of 0.5 meters. And so you can see here, these 3 tables provide the offsets for you, and they're at 3 separate sections along the canoe. So you've got one at 0 meters, 10 meters, and 20 meters. It's a very large canoe. And so you can look at that. Homework 242, the solution is always also provided. Okay, moving on from the homework. Let's now start talking about a different way to define geometry. So far we've talked about defining geometry as specific section shapes, but we can also define geometry using simple cut planes. So these are going to be planes that line up with your coordinate axis. And the reason this matters is because this form of defining geometry, it's much quicker than locus commands, and it's really handy for things like tanks. So you'll have a lot of tanks that are going to be basically following the shape of the hull, and then they're just going to have flat bulkheads on the forward and the aft. And these cut definitions make it very easy to quickly define tanks. And this is something you'll see a lot of GHS users will do to combine for efficient progress. Is what they'll do is they'll define the hull shape, or the shape of the hull, in Rhino, but then they go into PartMaker to define the tanks because of a lot of the customizations they can get. So let's show you how to use this geometry definition. So there are several different box planes that you can define, and the first of them are longitudinal end planes. This is specified with the command ends, ENDS, equals, and then it's the forward and aft location of your end planes here, and separated with a comma. Now you can also do the top or the bottom of your object. So top is going to be TOP equals, and bottom is going to be bottom equals. Now, if you just specify the first part, so if you just specify one vertical position, then it assumes a flat plane. However, maybe you've got a sloped plane, for example, then you can specify a vertical position at one point and a vertical position at another point. So it's V1 at longitudinal position and V2 at another longitudinal position. And that gives you a sloping bottom, a sloping top, or a sloping bottom. And then finally, we've got inboard and outboard planes. So to put this in orientation, the longitudinal planes, these are going to be YZ cut planes. They're going to be in the YZ plane. Top and bottom planes, these are going to be in the XY plane. And inboard and outboard planes, those will be in the XZ plane. Okay, so we have inboard equals and outboard equals. And this is the same idea as top and bottom. If you just specify a transverse coordinate, it's one flat straight plane, and it lines up with the x-axis. Whereas if you specify a transverse with a longitudinal coordinate, then you're going to get a sloping plane. Now, all of those commands, I'm going to go back a second, and all of these commands, top, bottom, ends, inboard, outboard, you can combine them all together, you can leave them out in any combination you want, and if you do it that way, then you're going to create a box, which is okay for some tanks. But most tanks are fit into the hull. They take up the corners of the hull. And so this fit command, when you combine those box commands with this fit command, that's when you get the ability to very easily define a tank from the hull itself. And the way the fit command works is like a Boolean subtract. So you're going to define a box, more or less, for your new part and tell it to fit the new part to some other part. And it takes the geometry from that other part and copies it in within the section that you've specified to your new tank part. So you can do that as an internal fit or as an external fit. And the way you do that is you issue this command from the part that you want to get cut. And this is probably easier just to show as an example. So for example here, modify, we're modifying this tank 1 part. And what I'm doing is I'm going to fit it. Internal fit, So it's only going to take the volume that's internal to the hull. So what that's saying now is it's going to actually cut out this part by the definition of the hull geometry. And so my tank now has the same shape as my hull. And that's pretty neat, because when you combine that with all of these other parts, now you can define the longitudinal extents of your tank, the inboard bulkheads of your tank, and then you can tell it any part that I've left, or any section of the tank that I've left undefined, at the end you say fit it to my hull. So let's show you an example with combining all of those things together. So what you do is you create the tank, you specify your geometry, and once you've specified the geometry, then we're going to get into specifying some of the properties of that tank. So we're going to specify the permeability, we're going to specify the contents, and then we'll close out our part creation. So you can see here we've got the ends created. So you're specifying longitudinal bulkheads, or excuse me, transverse bulkheads at 5 meters aft and at 10 meters aft. And then we're specifying the top of the tank, which is 0.5 meters above. And notice we've left everything else undefined. And I'm telling it, fit everything else to the hull. So you can think about that is draw a plane at 5 meters and at 10 meters, and draw a horizontal plane at 0.5 meters above. Every other place this tank is expanding out infinitely until I tell it to get cut by fitting to the hull. And then finally we specify the permeability and the contents of the tank and close it out. So the contents are whatever the liquid is. Right, so as you saw, there were 2 new commands in that tank command. The first one is permeability. The permeability, it's the effective amount of volume within a tank. And this is important for both the flooding and the capacity of a tank. It's not going to be specific to any one region of the tank, it's just a general reduction in volume. And so, for example, you type permeability equals 0.6. The permeability can be any number from 0 to 1. And it's basically saying 1 is 100% of the geometric volume. 0.6 here, that is 60% of the geometric volume. And the twin to that is effectiveness. Effectiveness works the same as permeability, but it's used on hull parts. So if you're talking about a hull, you use the effectiveness command. If you're talking about a tank, you use the permeability command. Now the other command that you saw in there was tank contents. So that's contents equals, and then whatever your description is. That specifies the fluid that is actually inside your tank. And you give it a name, and then also its density, which is specified as specific gravity. So here's a list. You have a table here. These are all the built-in contents. These are the contents GHS already knows about. You don't have to tell it the specific gravity. You just have to tell it the name, and GHS automatically knows the specific gravity. So you've got FW for freshwater, SW for saltwater, FO for fuel, DO for diesel, LO for lube oil, and HO for hydraulic oil. Now, notice that a lot of those were abbreviated to 2-letter abbreviations. That's pretty common in GHS. In fact, most of the commands in GHS can be abbreviated to just the first 2 letters of the command, and GHS will actually understand that. So a lot of the times you might see people do that. It's just because they're saving on typing effort. Okay, so let's talk about some interesting things to combine for parts. This is where you start getting into some pretty neat stuff with PartMaker. Let's say you wanted to create a negative volume in a space. There are 2 ways to do that. The first option is to to create your part like normal, say create a normal tank, and then actually give it a negative permeability. So I was kind of a little misleading at first when I said that your permeability can be any number from 0 to 1. Well, it can actually go all the way down to -1. And so any permeability below 0 is a negative volume. Same way for effectiveness. So that's one way you can create a negative volume, is you just set your permeability to negative numbers, but do everything else like normal. The other way is with the deduct command. Now, the deduct, it's another option to create a new component within a part. And instead of telling GHS the command component, you tell GHS the command deduct with the component name. Now, the deduct command, all that does is you're going to create your part like normal underneath the deduct command, and whatever permeability that you specify in there, deduct is just going to tell GHS to take whatever your permeability is and multiply it by -1. So that's all that deduct does. It's not very fancy. Now there is a catch to all of this. If you're going to create a negative volume and it's part of some larger component, then the permeability of that negative volume has to match the volume you subtract from, not the object causing the subtraction. So let's go back to our barge here to show an example. Now, as you remember, this barge, we have right here, this is our main engine room, and we have a lube oil tank and a hydraulic oil tank in that engine room. And if I look down here, my lube oil tank, has a permeability of 0.95. So that's 95%. And if I look right over here to my engine room has a permeability of 0.85, 85%. So now let's think about this for combining these two things. Go back to our engine room. Now, I'm going to create my engine room as one part, right? But then I've also got to cut out a volume from my engine room. I have to create a negative volume to create a space that I can put the lube oil tank in there. Because there's nothing in GHS that will stop you from putting and nesting parts within each other. GHS has no problem with that. It's not looking for any form of conservation of volume. It doesn't care about that, so you have to manually check all of that. So let's think about that. So this space here, this engine room, has an 85% permeability. Whereas this space here, the lube oil tank, the tank itself, has a 95% permeability. But before I create that tank, I should also create the hole in the engine room that my tank fills. So that's the negative volume as underneath my engine room, and it's going to be the shape of the lube oil tank. Now the shape and size of the lube oil tank, but not the tank itself. So the permeability of the hole, the negative volume, has a permeability of negative 0.85. We match the space that we are creating the volume, or taking the volume from. Separately, in a different create command, we create our lube oil tank. That has its own space, it's its own part, and it has an entirely different permeability, which is 0.95. Okay, so I just wanted to get that part across. Returning to the deduct command, I just wanted to create this example here. Honestly, you'll you've noticed I'm not very enthusiastic about the deduct command, which is mostly because it doesn't do anything fancy. All it is doing is adjusting the permeability. You can do that yourself, and it's one less thing to remember. But if you ever want to use the deduct command, here's how you do it. So you're at the top level here, you're creating the tank. Now remember that this is always a part, and then it's assumed to have a component as part of that. And we just have some information here to define that tank part. And I want to deduct something from it. So I enter the deduct command, and that is now creating a separate component under that part. And notice I'm fitting it to the tank1.s. That's the tank1.s component. So just remember how those all nestle together. The other option is that you could create a separate component with the deduct example and then actually use that in a new part. So there's several different ways you can do it. Okay, so sail parts. The way you create a sail part in PartMaker is with the class equals sail. You can use any type of geometry, as we've talked about before. One special thing you can do now is you can specify what's called a shape factor. And that's with this command here, you type SF equals and then your factor, which can be anything from 0 to 2. Now, the way the shape factor works, if you've ever used the API manual, that's where the shape factor comes in. It's GHS's very simple attempt to more or less account for drag coefficients of your different superstructure parts. And the way GHS actually applies it is this is just a straight multiplier on whatever GHS calculates as your lateral plane area. So, if your lateral plane area was, say, 10 square meters and you had a shape factor of 2, GHS would calculate your wind heeling moment, then assuming that you had 10 square meters times 2, so 20 square meters. So that's how the shape factor works. Okay, I want to finish up with a few more useful commands for PartMaker. These are ones that you're just going to end up using them to support things quite a bit. First off, deleting a part. That's with the delete command. And you can specify it as a part or as a component level. And then create a mirrored part. This is very, very useful because a lot of the times in GHS, or a lot of the times in ships, our tanks are mirror images of each other about the center line. Now, you don't want to create the tank itself as a single mirrored part. You don't want your port and your starboard tank to be one part. Don't do that. Because if you do that, GHS will think that fluid is free to transfer between the two halves of the tank. And that's not usually the case. So what you do instead is you create a tank on just one side, and then you use the opposite command. So the opposite command here to tell GHS when you're creating the other side to use all the information from its flip side. So for here's an example. We're creating a tank on the port side, and the very next command I issue is opposite the same tank on the starboard side. And that's all you have to do. Close it out, and GHS copies all the information from the starboard tank. Now, if you wanted to change a few things, like your tank name, for example, you can issue the opposite command and then follow that with any other things that you wanted to redefine, like your tank name. Okay, now it's time to combine everything together. So going to go back now to homework number 243. This is actually going to be creating that entire barge just using PartMaker. Don't do this in interactive mode. Write it out in a text file and try using GHS to run the text file. So just a few reminders. The stern notch you're going to use as a negative displacement. The engine room and the LNG tanks, they have their own special contents that you're going to have to work on. You're going to include some of the following features. All of your tanks need to have permeabilities. All of your tanks need to have contents. You're going to define the engine room tunnel as a component of the engine room. So if I bring you over the drawing of this barge, right, so here we have our engine room, and notice we have this tunnel that's going down the engine room. That tunnel, what you're going to do is create this part of the engine room as one component, and then create this tunnel as a separate component. And when you do it that way, you're going to save yourself a lot of effort. Trust me on this. Also, don't forget the lube oil and hydraulic oil tanks are deducted from the engine room. I spent a lot of time talking about how you've got to get your permeabilities right for that. And if you're really feeling adventurous for extra credit, you can also use these to find the sounding tubes for every single tank. Now, remember, you're going to define the entire homework in PartMaker only. And I want you to do it in PartMaker only because everybody should do this once to then have a very good understanding of the level of effort it takes to create an entire ship in PartMaker. Okay, thank you very much for watching. I hope you've enjoyed this video and found it informational. You can find files for all of the homeworks, plus solutions for all of the homeworks, and several other videos on dmsonline.us. Thanks very much.